Hi friends, once again welcome back in our educational channel, that is Precise Electronics. Friends, in previous video lecture we had studied series combination of resistors in series combination. And in today's video lecture we are going to find out the resistors in parallel combination. Friends, in series combination, one terminal of a resistor is connected to the second terminal of resistor and second terminal is connected to the third terminal, and in this case resistors are connected in single line. So obviously there is a single path for current conduction. So current flowing through R1, that is I1, must be same, that is current flowing through R2 and R3. That means in this case the current flowing through each resistor is of same value. Is of same value. And in series combination, when the resistors are connected in series, the total resistors of that network get more than the resistors connected in this network. For example, in last lecture we had studied 10 and 12 ohm resistors which are connected in series. Suppose this is 10 ohm resistor, this is 12 ohm resistors. When they are connected in series in a single line, the total resistance becomes 22 ohm. So series combination is used to increase the resistance value. Now we are moving toward the parallel combination. When the resistors are connected in parallel, how they are connected in parallel mode? When the first terminal of first resistor is connected to the first terminal of second resistor and the second terminal of first resistor is connected to the second terminal of second resistor, then these resistors are said to be in parallel combinations. So this is the mode, this is the way how these resistors are connected in shunt. Suppose one more resistor is used, suppose there are three resistors, and in this case all these three resistors are connected in shunt. In parallel network, the current flowing through their circuit takes more than one path. In series combination there is a single path, but in this case suppose there are two resistors, the applied current flowing because of this applied potential battery, that is I, this current is divided and current flows through resistor R1, that is considered as I1, current flowing through resistor R2, that is considered as I2. That means the current is divided between the two paths. So in this case there are two paths. So as many resistors are connected, that much paths are provided for the current. So because of this, in this case the current is divided into two parts, and hence this network is also considered as current divider. The current is divided between these two currents, that is I1 and I2. Friends, how the resistors are connected in shunt? The circuit diagram of that resistors connected in shunt is now going to be displayed on your screen. In this circuit, the three resistors R1, R2 and R3 are connected. The battery having potential V is connected in the circuit, and because of this battery, because of this supply potential, the current conduction takes place. And this current is divided into three different paths. That is the I1, I2 and I3. I1 is a current flowing through resistor R1, while I2 is a current flowing through resistor R2, and I3 is a current flowing through resistor R3. So applied current is divided into three parts, that is the I1, I2 and I3. Resistors R1, R2, R3 connected in parallel. V is the applied potential. I1, I2, I3 are a respective current flowing through each resistor, that is R1, R2, R3. Now the current flowing through resistor is calculated by using a formula, that is Ohm's law. What is Ohm's law? V is proportional to I is proportional to V, or V is equal to IR, or I is equal to V upon R. So I is equal to V upon R. This formula is used to find out the current flowing through the circuit. So I1, that is current flowing through first resistor R1, that is equal to V1 upon R1. I2, that is current flowing through second resistor, that is equal to V2 upon R2. I3, that is current flowing through third resistor R3, that is equal to V3 upon R3. So I1, I2, I3 is equal to V1 upon R1, V2 upon R2 and V3 upon R3. That is our equation number 1. Now by applying Ohm's law to the equivalent circuit. What is the equivalent circuit? It is R1, R2, R3 are connected in circuit. The total resistance is considered as RT. So current flowing through RT, that is IT, total current. So IT is equal to V upon RT. V, that is applied potential. And friends, in this case, when the resistors are connected in shunt, the potential drop developed across each resistor may be same. So obviously V1 is equal to V2 is equal to V3 is equal to applied potential V, or it is VT. In this circuit, there are three different paths for current conduction. So current flows through resistor R1, R2 and R3. So there are three different paths. So in this case, we can apply junction law, that is Kirchhoff's current law. What is the Kirchhoff's current law? The algebraic sum of current flowing toward the junction is equal to the algebraic sum of current flowing away from the junction. The current flowing toward the junction, that is IT, total current, that must be equal to I1 plus I2 plus I3. That is our equation number 3. Now by substituting the values of equation number 1, that is values of I1, I2 and I3, in third equation we get V upon RT is equal to V1 upon R1 plus V2 upon R2 plus V3 upon R3. But friends, V1 is equal to V2 is equal to V3, that is a common. So in next equation we get V upon RT is equal to V in bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3. That is our next equation, equation number 4. As voltage is common, so that voltage gets cancelled. V upon RT, V in bracket 1 plus R1 plus 1 plus R2 plus 1 plus R3, that VV gets cancelled. So the equation number 4 now becomes 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Suppose the n number of resistors are connected in this circuit. In this case, only 3 resistors are connected. So total resistance given by 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. That means a reciprocal of total resistance is equal to summation of reciprocal of resistance. Suppose n number of resistors are connected in circuits, that is R1, R2, R3 dot 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 Rn. Then the equation or the expression becomes 1 upon RT is equal to in bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus dot 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 Rn. So that is our final equation. Final equation of resistors which are connected in shunt or in parallel. From this equation it is clear that the parallel combination of resistor network is used to decrease the value of resistance. In series combination, it is used to increase the value of resistance. But in parallel combination, the complex or circuit, equivalent circuit, the resistance of equivalent circuit is less than the resistors which are connected in the circuit. So the parallel combination decreases the value of resistance. Suppose the 2 resistors are connected in the circuit. Only the 2 resistors are connected. Then what's happened? The circuit diagram of these 2 resistors parallel combination is displayed on your screen. In this case, R1 and R2 are connected in series. Battery having potential V is connected and applied current I is divided into 2 parts, that is I1 current flowing through R1, I2 current flowing through R2. In this case, what is total resistance? Equivalent resistance, that is equal to 1 upon RT is equal to 1 upon R1 plus 1 upon R2. There are only 2 resistors. So total resistance is equal to summation of total resistance is equal to summation of complement of resistance, reciprocal of resistance. So 1 upon R1 plus 1 upon R2, that gives a reciprocal of total resistance. Now 1 upon RT. Now we are going to solve this equation. 1 upon RT is equal to R2 plus R1 upon R2 into R1. Now we are going to solve this equation. 1 upon RT is equal to R2 plus R1 upon R1 into R2. RT, now RT is equal to, once again this equation gets simplified. So RT is equal to R1 into R2 upon R1 plus R2. That means the total resistance when the two resistors are connected in shunt, the total resistance is given by product of these resistors R1 by R2 divided by the addition of these two resistors. So RT is equal to R1 into R2 upon R1 plus R2. Suppose the two equal resistors are connected. The resistors having the same resistance value are connected in circuit, are connected in parallel. That means R1 is equal to R2. Then we get RT is equal to R1 into R1 because R2 is equal to R1. So RT is equal to R1 into R1 upon R1 plus R1. So R1 into R1 upon 2R1. So R1 gets cancelled. So RT is equal to R1 upon 2. That means when the two equal value resistors are connected in shunt, the equal resistance is half that of applied resistance. The value of total resistance, equivalent resistance, is now half that of resistance value. So friend, that is the shunt combination of or parallel combination of resistors. Some important parallel combinations which are used in our entrance exam, JEE exams or CET exams, that parallel combination circuits are now going to display on your screen. In first diagram, the two resistors R1 and R2 are connected in shunt. In second diagram, the second diagram is now going to display on your screen. In this diagram, R1, R2, R3 are connected in shunt. R1, R2, R3 and R4. So all these four resistors are connected in shunt. In next diagram, R1, R2 and R3. First R1, then next R2 and next R3. These three resistors, they are also connected in shunt. In next diagram, in next fourth diagram, R1, R2 and R3. They are connected in this way, just like a pyramids. But in this case also, resistors R1, R2 and R3 are connected in shunt or connected in parallel. And one more diagram, that is fifth diagram, is also displayed on your screen, in which R1, then R2 and then R3, the three resistors are connected in shunt. In next video lecture, we are going to solve the numericals on series and parallel combination. We have to find out the total resistance when the resistors are connected in series as well as in parallel combination. So friends, that is a shunt combination or parallel combination of resistors. So friends, thanks for watching this video lecture. Bye. Take care. In next lecture, we are going to solve the numericals on series and parallel combination of resistors. So bye. Take care. See you again.